It's Thursday. Week 3 almost done. The only thing we have tomorrow is capstone. The students are working on cyber defense. Which is Saturday. Network security. We're finishing up connecting networks. Pretty close to wrapping it up. We did a little bit on quality of service today, and then they worked on the access lists. They got that. That was completed to my best knowledge. That makes sense. We did not talk much about network evolution, so we'll wrap up on Monday. We'll wrap up items from, or I'd take that back, it won't be Monday. It would be Tuesday. We'll wrap up the connecting networks, do a little bit on network evolution and troubleshooting, and then we'll get started in the security material, which will be fun. That'll be interesting. Today we just talked about, we have different types of traffic, let's say web browsing, and there's, you could categorize the data in a number of ways, and a lot of times that traffic needs to be organized onto, aggregated to one line. Like if you're going to the internet, eventually you've got a fiber optic line going from there to there. Plus this goes through all kinds of intermediate equipment. So we're limited with a certain amount of bandwidth. Sometimes we don't know how much congestion there's going to be. We have the whole situation of latency in general. There can be delay, and then we'll talk a little bit about jitter. Jitter is the traffic leaves one place organized a certain time, but by the time it goes through all this equipment, when it gets to the other end, it may not, there may be timing spaces that are different. So we have latency within our networks. If nothing else, the equipment has to queue up the data, the packets, or frames or segments, however you want to term it, depending on where it is in the in your concept of thinking about this, and then it has to be moved. So we looked a little bit about at jitter, this idea that what you're sending may have gaps in it, or some packets may have been dropped, and a digital signal processor, let's say this is voice, is going to try to organize it back into an organized group in order to translate it into sound, let's say. So it may have to interpolate. So if there's something missing and it sees this kind of curve, it could pretty much guess in between there. You can pretty much guess what that might be. It sounds crazy, but it could. So it can interpolate. All right. We only talked about a couple of these, first in, first out. Weighted fair queuing is going to look at the information that's coming. An example might be if you have downloading a file and you have all that information, and a small file that needs to move through, it can actually, put that into the queue and get that through, and not hardly being noticed here on your download. So some small, you could go to a grocery store, somebody comes up to you and you got a cart full and they say, hey, I just got 2 items. You say, hey, yeah, you go ahead of me. Kind of the same idea. We can do that. We can classify the data, have that class-based. We didn't go into low latency queuing, but there's ways to set up queuing, kind of what I just talked about here. how to move the traffic through the device when you have ingress and egress and you're going to queue up traffic, how you're going to handle it. We'll wrap that up on Tuesday, talk a little bit about network evolution, and then get started on security.